Hello everyone, welcome to the Math Bender. I'm Adnan Zaidi and this is my second video on tan sketching. I will discuss about the transition on the tan curve and how can that be applied. So in our previous lecture, we talked about how tan function has a period by default of 180 degrees or pi radian. So keeping that in mind, we will proceed further. So let's say if it is tan 2x, and how would we be sketching that? So tan 2x means that there are going to be two waves, two cycles within that 180 degree. So I'll draw both of them. So the first wave is like this, and the second wave continues like this. And if I have to draw these asymptotes line, and they're not touching the curve, by the way, so disclaimer. So this is my tan curve. The last point will be 180 degrees now because there are two cycles completed in that. So midway is going to be 90, and if you remember, we can divide it, this 180 degree, in 1, 2, 3, 4, 5, 6, 7, 8 points. And if I divide 180 by 8, so I'll get approximately 22.5. Although you don't have to go into that much of a detail, but if I have to just write down the main values, it will be 45 will be the asymptote, and 135 now the asymptote lines. Each value is going to be 22.5, and so on if you want to divide. So by default, period is going to be 180 over 2. This value is divided by 2, which is going to be 90 degrees. So which means one wave of tan curve completes in 90 degrees. So if I have to draw tan 3x, so which means there will be three waves completed within 180 degree, where there is a space for only one cycle under tan x. Tan 3x will cover three cycles. So let's try to draw. I'll draw the asymptote line here. One wave, then the second wave, and then the third wave. Now, so marking these values, so this last value is 180. I'll divide these so into 1, 2, 3, 4, 5, and 6 equal intervals. So if I divide 180 by 6, it's going to be 30, 60, 90, 120, 150, and 180 degrees. By default, the period of this wave is going to be 180 degree over 3, which is going to be 60 degree. So within 60 degree, the wave completes. Then half x means that in 180 degree, I'll have a big space to draw this one. So now tan half x mean that the graph will have half of wave completed until 180 degree. So I can see that this amount of wave, this wave is the half wave of tan x, and it is completed where normally 90 degree is. So I'll straight away write this as 180 degree, and the wave completes at 360. So this is half x. I've just drawn this function from 0 is less than equals to x is less than equals to 360 degree. My domain changes. Every other curve that I've been drawing was until 180 degree. So I just wanted to draw it further. So I drew it till 360 degree. If you had drawn half of it, that would have been as well, but depend on the domain of the question. So just for a change, so that you guys know, you the half means that half wave completes in 180 degree. So the period of this wave is going to be 180 divided by 0.5 or equals to 360 degree, which means that one complete wave will finish at 360 degree. So tan 3 over 2, which means 1.5 wave completes in 180 degree. So let's draw that. So this is how tan half x will look like. The last point where the graph reaches infinity again will be 180 degrees. So this point here is 180. Now if I divide this into 1, 2, 3, then 60, 120 and 180. You can further divide it although if you wish to, tan 30. So 30, 60, 90 somewhere where negative 1 reaches, 150 and so on. The range of this function is going to be negative infinity to infinity. Is pretty much clear right there. The period is going to be 180 degree, which is by default one wave size of tan x, divided by 3 over 2, or I can write this as 180 times with 2 over 3, which is equals to 120 degree, as you could see in the graph that the one wave completes at in 120 degrees. Let's look at some more transitions. Negative f of x, we already established that negative of a function means reflection on the x-axis or y equals to 0. So I'll draw a basic tan function first, and then we'll try to reflect it. So drawing that parent function tan x with a lighter ink, so y is equals to tan x, and this is y equals to negative tan x, so which means it is going to be reflection, and I'll draw the reflection now. So it will be like this. So the highlighted one is the reflection now. And if I erase the parent function, this is how the negative tan x will look like. 180 degree, the value remains the same. This is 90 and this is 0. Now modulus of a function, if I draw first, so this is y equals to tan x, and this is the asymptote line, and this here is. Now notice that this is the negative part of the curve, this is the negative part of the curve, and this will reflect only. So the graph will look like this. And if I erase this, this value here is 180, the center is 90, 45, and at 135. Now the range of it will be 0 is less than equals to y is less than equals to, not equals to, it's the infinity. Infinity is something that we don't reach. So it will be less than infinity. F of x whole squared means that the negative of that function value will turn amplified, stretched, and positive. So in this scenario will be the same graph as the modulus, but do remember that modulus of -1 is 1, same goes square of -1 is also 1. So the value at 1 won't be seen as much of a difference, but the modulus of -2 is 2, but the square of -2 is +4. So the graph will be stretched, but since it's sketching, so it's going to be the same graph. You can draw this, but you just need to have an understanding that f of x whole square does not exactly mean that it is as same as modulus of x. So the range is going to be the same. F of -x, and this means that f of -x is tan of -x. Let's draw this. I will draw the main function first. Now, if you could see that if I draw minus tan of -x, it is a reflection on the y-axis. So the graph will be like this. So the graph is this one. The highlighting graph is tan of -x. This graph is tan of -x. Now, if you draw this function and further extend it, you will see that this graph will continue further and so on, which is exactly same as this function minus tan of x. So you can still say that we have an another identity, which is tan of -x is as same as minus tan of x. So if I have to draw tan of -x, I can draw minus tan of x, because reflection in the line y-axis looks exactly the same as reflection in the line x-axis for this function particularly. I'm not talking in general. So this is it. I will be uploading my handouts on tan function with a detailed description of all of the things that is happening here. Until then, take care. Bye bye.